turns out, in order to go live. So that is slowly starting to stream. For those of you who are joining, welcome. Alone, as always, it is a pleasure to see you. Christian, welcome. Eugene, sorry, I'm muting myself in the background. You are amazing, and we are always glad you're here. Evgeny, pleasure. Herv, pleasure. Elias and Izzy, we are better for who you are. Jessica, glad that you're here. Constantine, and so many others. I'm going to go ahead and I'm going to start clicking all of the buttons in the background where I can share this video on LinkedIn and YouTube and Slack and Telegram for all the people who we want to join us on the monthly release call. So we're going to get started here in just a few minutes. Bear with us and we'll kick off here in just a second. In the meantime, Alexei, if there's anything you want to say, please feel free.
Welcome. By the way, Tyler, you have a nice t-shirt or just a shirt. I don't have this model. Where did you get it?
Yeah, I made them myself because I can't wear yellow shirts. So I made some custom shirts for myself. I can make you one.
I would like to have one. But maybe we will make more for our regular attendees. If we will find someone who visited like at least 10 release webinars, they will deserve this t-shirt. By the way, are there any people who visited at least 10 webinars? Stefan, yeah, I remember you. Maybe also Ellen. Welcome, Ellen. Special welcome. Larry, nice to see you. Nice to see our contributors. We will start in about 2 or 3 minutes. Yeah, every single one since 21.10, and probably 21.10 was the first release webinar, or one of the first. And it will count about 30, probably about 30 release webinars. It's nice to see so many attendees. And we have so many features today. Ah, by the way, what is the text behind you, Tyler? Stop making sense or stop making fans?
Stop Making Sense. It's a Talking Heads album. So I listen to records in the office, and you have to pick the right record to for every call. And of course, to me, it makes sense that the record to choose when you were telling us about all of the new features that are coming to ClickHouse is Stop Making Sense, because inevitably all of the features make a lot of sense.
Okay, let's start.
Perfect.
Yeah, let me share. Okay, so this is ClickHouse release 24.6, ClickHouse summer release. We will spend most of the time talking about the new features. We will have about 5 minutes for our guests. And today we have a single guest. And maybe we will have time for your questions. So what do we have? 23 new features, 24 performance optimizations, and almost 60 bug fixes. Let's start with some nice, small, and probably not making any sense features. And the first one is about empty tuples. Until recently, it was not possible to use tuples that are entirely empty. You could only have tuples with at least a single element. But now it is easy. Look here. Here it is, empty tuple, magic. What is the purpose? Actually, there is almost no purpose besides completeness. Completeness and consistency, because if we have tuples with a single element, why don't allow empty tuples? And they will have a lot of use. By the way, this type of syntax we already supported with a slightly different mechanism. It was just a syntax sugar. If you want to specify an empty order by key or empty partition key, you just specify this empty tuple. Now you can also use it for attach, detach partition expression. If you don't have a partition key, just specify empty tuple. This is quite uninteresting. But let me show you something slightly more interesting. Let me find queries and copy paste some queries. And I will use ClickHouse local. Here it is. I run ClickHouse local with its shortcut CH. It is easy to use, easy to run. So here I will select a lot of different types of emptiness. Empty tuple, empty array, empty tuple containing empty array containing empty tuple, and not it was not empty array, it was array of single element, and an array of a single element containing a tuple with two elements. Both of them are empty arrays. And by the way, this makes a cute smiley face, or not smiley, but it looks cute. I like it. What for? I don't know, but let's explore the types of these expressions. I can use the subquery and select star and apply a function to type name for each column. And we will see empty tuple, array of nothing, tuple of array of nothing. Probably it is not so exciting for you, but let's take a look at all types of smiley faces. Two empty tuples. It looks nice. We can apply some operators to empty tuples like concatenate an empty tuple with empty tuple, and guess what will be the result? Dale, I want to ask you. Okay.
It will be an empty tuple.
You are absolutely right. How did you know? The answer is this is logic. The logic. Okay, what will happen if we sum two empty tuples? Dale, I need your help.
I'm going to say an array of two empty tuples.
No, it is element-wise sum. For example, if we do something like this, we will have this. And it is needed for vector math, because we can have vector embeddings, and when we sum vector embeddings, it will be a sum of vectors. But here is a slightly more tricky example. I would say it will not work like in JavaScript, don't worry. But it will work in its own way.
I'm not sure what we expect the overloaded, what we expect multiply to do. Do we expect it to do a pairwise, or do we expect it to do a? I'm going to say an empty tuple.
Okay, actually, here is a tricky one, because it is actually a scalar product. And a scalar product is a sum of element-wise products. And the neutral...
So zero.
Yeah, it will be zero. Not very intuitive, but it still makes some sense. Now this. What is this? But it looks surprising.
I have no idea. I have no idea what this is going to do.
Actually, this is not a tuple, this is just a star, and a star is selected from the default table containing a single column with value 0. Not quite interesting, and this will be easy. Okay, let's finish with these uninteresting examples, but I would say that actually you can even store empty tuples inside a table. I don't know why, but just for completeness, just to make it working. Okay, the next feature. A new function named generate snowflake ID. Just to know that it is not anyhow related to the company Snowflake. It is actually developed by Twitter, inside Twitter, to generate unique identifiers. Unique 64-bit identifiers containing the current time in highest bits and a sequential number in the least significant bits. It is quite similar to UUID, but more compact and more suitable as a key in tables. And we have functions to extract datetime or datetime 64 back from this Snowflake ID. This is quite easy, nothing interesting. So the next feature is support for base 64 for URLs. We already have functions like base 64 encode, base 64 decode, and try base 64 decode. Now we have a pair, actually not pair, 3 new functions: base 64 URL encode, base 64 URL decode, and try base 64 URL decode. And let's take a look what will happen if we encode this nice summer themed string. So here is this string, and here is base 64 encoding. And here is base 64 for URLs. And the difference is in these 3 symbols. Instead of plus, we use minus. Instead of slash, we use underscore. And we don't have a padding with equal signs. And it is URL safe. It can be used inside a URL parameter without additional URL encoding. Okay, it works. Now we have this function. The next one is another new function, parse readable size. It is the opposite of format readable size. If you call format readable size, it will return you a string, something like 1 GB in binary gigabytes. With parse readable size, you can parse it back. And it works regardless if it is binary or decimal gigabytes. It works correctly in every case. There is also a function parse readable size or null and parse readable size or 0. Another new function, edit distance UTF-8. It is just a small modification to already existing function, edit distance. But the function edit distance calculates the distance in the number of bytes that you have to insert, remove, or replace to make another string from the existing string. So here we have 2 strings, one with a nice French touch, and another with just a uninteresting English. And the difference in bytes is actually 4. Here is a Unicode code point containing 2 bytes and another Unicode code point. But the difference in Unicode code points is actually 2 bytes as expected. Now about virtual columns. For table engines and table functions, file or URL or S3 or HDFS or Azure Blob Storage, the functions that allow you to just read a bunch of files. In addition to the columns from these files, you can also get virtual columns about the metadata of these files, such as path, file, and now also the modification time. That's easy. It works. Let's go ahead. A small modification to data types IPv4 and IPv6. Until recently, they were not comparable. You write comparison operator and it gives you an exception. But now it can perfectly compare IPv4 with the corresponding IPv6 that is IPv4 mapped to IPv6. And this is a special case of IPv4 that looks like this. First 0 bits, then 2 bytes with 255, and then 4 bytes with IPv4. And it should not be confused if you write something like this. Here is localhost in IPv4, and here is localhost in IPv6, but they are actually different. If you look at IPv6 address, that is IPv4 mapped to IPv6 corresponding to this IPv4, it will be this address, not this address. So this will not be considered equal. And the same as this is also slightly different. So take care and carry on. Okay. What about boring security features? We have a few. First of all is about the system query log table. Now it has 2 more columns about used privileges. If the query succeeded, it will contain the privileges that this query used. And missing privileges, it will contain privileges that were missing if the query was rejected. And it is nice because you can just paste this into a grant table statement, and it will grant the missing privileges. And this one is about a limitation like a safety threshold. Safety protection. Protection from too large number of tables. These are server's level settings that you can set inside the server config file. And there are 4 settings. Max database number to make a warning, max table number to make a warning, max database number to throw an exception, and max table number to throw an exception. First of all, a question for you. How many tables any reasonable person will have enough in ClickHouse? What will be enough for any reasonable ClickHouse user? First of all, I want to ask Tyler. Tyler, what do you think? How many tables would you like to have in ClickHouse at the maximum?
I have a strong and undying belief in the notion of wide tables, so I would love to decrease them as much as possible. So it depends on workload, of course, and what data that you're storing. But for me, I'd love to keep the number of tables under 100 if feasible.
Okay, I like it. But what about Dale? What about you? What do you think?
I think a couple of thousand, 1,000 to 10,000 is probably I would say would not exceed those limits. But I can see use cases where people need 1,000, where they have many customers and they need to isolate their data in different tables, multi-tenant scenarios.
Yeah, this is generous. This is quite generous. About me, actually, I would like to let people have at least 50,000 tables, because some customers in ClickHouse Cloud have this and even a larger number of tables. But there should be a limit somewhere. And starting from some threshold, like 10,000 or 5,000, we should just warn a user that maybe this number of tables is not right. Maybe you have to forget your practices that you have used for some ancient version of MySQL when you are professional and you do manual partitioning. Forget about manual partitioning. You don't need it in ClickHouse. In ClickHouse, just create a table and insert 10 trillion records in this table, and don't worry. Okay, now we have this feature, and this is nice. Okay, what for usability? First of all, the documentation for system tables. Let me show it for you. So here is ClickHouse local, the same ClickHouse local, and straight inside the system table, I have a comment describing every system table. For example, there is a table system.asynchronous inserts, and it contains information about asynchronous inserts that are still in the queue. Perfect. By the way, we also have comments for every column. For example, what if we will do show create table system asynchronous inserts? Actually, the metadata for this table does not exist, but what about like query log? And we don't have query log. Probably it is on the server. Here it is. We have a comment for every column. And we have a comment about the table. And yet another feature is about pretty formats inside ClickHouse client. Let me demonstrate this feature. So the same query, and it returns this result with all the comments. And here is the table header. It contains column names. And the difference in the new version 24.6 is actually a very small, subtle difference, but it makes sense. It makes the difference. I like it so much. So now we also have this table header that is actually a footer. And it works for every pretty format, like pretty space. Here it is. And it looks just amazing. So thank you, Sean Struik, for implementing this feature. I like it so much. Now, what about performance improvements? We continue to improve and improve and improve performance in every version. And I want to highlight just a few items. The first one is quite interesting. It is about the possibility to automatically select table ordering. When you create a table with merge tree family, and the merge tree is by default, you specify the ordering key. And in this example, we have a table with page views, probably for website page views, and we sort by the counter, like a website identifier and a user identifier. That's easy. And this ordering key actually has at least 3 different purposes. First of all, it serves as an index. If you will do a query with range requests like counter ID equals to 1 to 3 and user ID equals to 5, 6, 7, this query will be processed quickly. The table is ordered by this key. The data is located inside a single granule. A single granule will be read. The second purpose is to support different special modes of operation of merge tree tables. There are special types of merge tree, like replacing merge tree or aggregating merge tree. And this order key will be responsible for aggregating the data. So for every key, it will be aggregated or replaced or collapsed, depending on the type of merge tree table that you have created. And the third purpose is to improve compression by sorting. If the data is sorted in some optimal way, it can be compressed better. And you might think that maybe you should include more columns into order by key, like event time. Why not? Why don't sort page views by every user by event time? Most likely, also URLs will be similar, and they will be compressed better. And this is true. But the question is it possible to make it automatic? And now it is possible. Just enable a single setting. Optimize row order, set to true. And for every range of values for identical key, it will additionally sort this range in some optimal way. And this optimal way can be different in every granule. It will be optimized for better compression. Okay, maybe difficult to explain, but let me show you it in practice. I have a table that is quite interesting. And I have a data set. Let me show you this data set. It contains a bunch of JSON files. And the total size is 32 gigabytes. We have 32 gigabytes of JSON. This is natural. Let's take a look at some of this JSON. And it looks like a newspaper, like London, British fighter planes clashed. I will not read it. It is probably depressing from 1940. And it is quite a big JSON. And what we can do is, again, run ClickHouse local. ClickHouse local is just the best tool for data exploration, data processing on your local machine. And I will do some settings, like I don't like nullable, so I disable schema inference for nullable. And I will create two tables. One table will be named newswire, it will be merge tree, and with schema automatically derived from this JSON data, automatically inferred. And there will be no primary key, no key at all. It is normal. And another table with this setting. Now I will increase the number of threads because I don't like to wait. I want my insert to be as fast as possible. So I set max insert threads to 64. And now I will do my insert. It is as easy as insert select star from star.json. Now, a question for everyone from the audience. What do you think? How long it will take to parse 32 gigabytes of JSON and insert all the data into merge tree table? I will give everyone just 5 seconds to answer. Please don't say it will take 5 seconds. Okay, Dale, let's collect some answers if you don't mind.
We only have one answer, which is 10 seconds. Oh, 55 seconds. Two answers, 55 and 10. And I'm going to say 25.
Let's be optimistic. So we have 3 answers, 10, 25.
We have a 3-minute answer as well, but I didn't want to upset you. And we also have a 16-second answer. Less than 3 seconds, I think, is very optimistic. I think you should press. I'll let you know who's closest.
Okay, by the way, I will turn off ClickHouse server because I don't need it. I will use just ClickHouse local. Let's run it. Okay. 2 gigabytes per second. Not bad. 8 seconds. It is faster than 10 seconds, but slower than 3 seconds. So optimists win. Now let's insert into a table that will automatically try to additionally sort data in the best possible way. Will it be slower? If it will be slower, for how much? One gigabyte, 1.5, 1.7, not bad, but it looks slower, just a bit. So it was 8 seconds and 14 seconds. It is slightly more than 1.5 times slower, but was it worth it? Let's take a look. We have 2 tables with identical data, just with different order. And we will use a system tables table to calculate compression ratio and uncompressed size. And the first table takes 5 gigabytes. It is already pretty good because JSON data took 33 gigabytes or 32. But the second table takes much less amount, 400 megabytes less, just 4.6 gigabytes. And the compression ratio is improved for about maybe 7% or 8%, something like this. So it's a clear win. But just in case, let's take a look. What is this data? And this data is about news from official sources for about a century. Actually, for more than a century. And we can process this JSON, including nested fields just straight ahead. And let's calculate a graph of mentions about some person with name Churchill. And it looks like Churchill was not quite popular, but starting from 1938, he became popular and very popular in 1933, and then slightly less popular, and then again more popular, and in 1965 stopped to be popular again. It's interesting, and the query took just 29 milliseconds. It is so fast for 33 gigabytes of JSON. By the way, what do you think will happen if instead of this, the fastest table engine in ClickHouse, I will just process JSON data as is? How long it will take? Dale, your answer.
I'm going to say 12 seconds.
Maybe. No, it took not 12, but 2 seconds. Your answer was too much off, way off. And the result is exactly the same, but I prefer 28 milliseconds. Okay, so optimal table sorting, it makes sense. Another optimization is the possibility to disable the calculation of secondary indexes on inserts. Secondary indexes will still be calculated, but during background operations like merges, you can just make inserts slightly faster by postponing these calculations to the merges stage. It is useful if you have a large number of complex indexes and you want as fast inserts, as little latency as possible. And by the way, it will not really affect performance of selects because just inserted data typically takes only a small amount relative to the table size. Okay, let's take a look at something even more interesting. And something even more interesting is support for sharing named collections between all the servers in a cluster by storing named collections in Keeper. So let me explain what it is. It is easy to configure. You just add a server configuration, name it like this, named collections storage. Type will be Keeper, a path inside Keeper, and optionally a refresh timeout. And what are named collections for? Named collections are to encapsulate and hide configurations of addresses and credentials for external databases. You don't want to let user to type the password for MySQL every time, but you still want your user to connect to MySQL. You just create a named collection with a specific name and with specific amount of key value pairs like host, port, password. You grant access to this named collection, and the user will use it just by name, like select star from MySQL with the name and with possibly some overrides, like a specific table, and it will use all the parameters, including password. Until recently, it was possible to do it on a single server. Now it is possible to store named collections inside Keeper, and this is nice. And this is even nicer and more beautiful. New functions to work with Hilbert curves. We already have a few functions to work with Morton curves, but Morton is one person, and Hilbert is another person, and both people are really good mathematicians. And they used to write about space filling curves. So it happened that these space filling curves are named after these people. Probably some of you have no idea what it is, but let me explain. Let's imagine you have a table with a few columns that are similar, and you don't know which will be the primary key. Sometimes you select the data by a range of X. Sometimes you select data by a range of Y. And sometimes you select the data by a rectangle. So you limit both variables. And there is no optimal sorting if you sort by a single column. If you sort by X, you will get fast queries by one column and slow queries by another column, and vice versa. But with this function, you can mix together these two columns. The order will be split data by one column, then by another column, and so on. So let me show you some demo. First of all, let's take a look what will happen if we will just mix two values with Morton encode function and with Hilbert encode function. And you will get a larger number that contains the information from both these numbers. And Morton encode will mix them in one way, and Hilbert encode will mix them in another way. And it is not so easy to explain what is the difference, but let me try. And you can always convert this back, take a large number and extract two source numbers. Now let's try to take natural numbers from 0, 0, 1, 2, 3, etc., and order them by this encoded value. And they will be, and we will split into two coordinates. So let's take a look. What will happen? And these two coordinates will be ordered by some order, but this order will be not by a single coordinate, but by a mix. So it will go in a strange direction that we actually need to visualize this. Let's try to visualize. And to do it, let me open ClickHouse Playground. And in ClickHouse Playground, we can make a graph of this ordering. This is interesting. Do you see anything here? It is a space filling curve. So it is not a mistake. It is named a space filling curve because it fills this space and it fills the space in a very elegant way. It is continuous. If you look the forward transformation, actually, if you take the backward transformation, it will be continuous. But if you take forward transformation, it will be sometimes discontinuous. But let me not go into this detail. Let me also try to use our SQL console to visualize this curve. Oh, see, it looks really nice. But what is the difference between Hilbert and Morton curve? And the Morton curve looks like this. it is not always continuous. Sometimes it jumps in a very long distance. And the difference is that Hilbert curve is just a little bit better. I actually need more arguments to explain it, because it is not so easy. And to tell about it, I have a website named reversedns.space. Dale, could you please explain what it is? Because probably my explanation will be very confusing.
I believe you've color-coded this map such that the hierarchy of the DNS space, domains with the same prefix are all the same color, and as you go in, the prefix gets longer. The common domain name has to get longer.
Yeah, exactly. So this is the map of the internet. Almost all the internet, at least its IPv4 part. It contains 4 billion IP addresses, and for each IP address, I did a reverse DNS request to obtain a name of this IP address. For example, this magenta colored part related to SoftBank. I don't know why SoftBank should have so many IP addresses. And here another pink part is related to Comcast. This is nice. It is very deep. I like to play with it. Boundaryissues.com. Okay, but to visualize IPv4 addresses, I ordered them from 0 to 4 billion. And then I mapped this order to this square using the Morton curve function. And now we can also try the new function, Hilbert curve. And it looks like this. Is it better? I don't see much difference, but actually it is better. Look at this pink square. Something named proxad.net. I don't know what it is. It is not even correct. In this picture, actually it is Comcast. In this picture, Comcast is not actually a square. It is spread to this strange figure. But here, due to slightly better encoding, it is a perfect square. So I hope I convinced you that it is better. Actually, I have slightly more pictures to explain. I generated some pictures. For example, here is a visualization of a Morton curve by mapping HSV color space into a square. It starts here and it goes in zigzag direction. And here I have a similar visualization, but using a Hilbert curve. And it looks better. I'm not sure if it looks better for you, but for me, it looks better. Okay, I hope I convinced you that this feature makes just a bit of sense. Okay, what else do we have? First, about CHDB. Today, we have a new release, CHDB 2.0. And let me remind you that CHDB is ClickHouse, full ClickHouse engine embedded into your Python script or Go application. It runs in process, and you can do your familiar ClickHouse queries on pandas data frames, on arrow tables, on dict, or any Python object like this. Select something from Python And the main highlight, it is 87x faster. I don't know why, but just think about it. 87 times faster. Another new feature is about our SQL console in ClickHouse Cloud. Now you have an interface to monitor the performance of your queries. Your queries will be normalized to different classes of queries, and for every query you can see profile events, you can see latency by time, errors by time, query volume, etc. Open source trust center. It is located at trust.clickhouse.com. You can subscribe to early notification about vulnerabilities. Typically, when a vulnerability is reported, and it happens sometimes, it is disclosed only after 90 days of discovery. But if you subscribe to trust.clickhouse.com, you can receive embargoed notification, so you can patch your applications earlier. And I strongly suggest you to do it. And just in case, we are currently CVE numbering authority. There are only 300 or so companies that are CNA, and we are one of them. Okay, and this is even more interesting. We submitted a scientific paper on 50th International Conference on Very Large Databases, VLDB. It will happen in Guangzhou at the end of August. And it is actually the first academic paper from ClickHouse about ClickHouse in 15 years. So we developed ClickHouse for 15 years, and we did not even bother to write a paper. And it is a shame. Now we have a paper, and it is not a shame. Okay, what about integrations? And first, let me introduce Sergey, who is our guest here. He will tell about the driver.
Today I'm a member of integrations team, and today I would like to present our big work of refactoring Java client. First of all, we started with redesigning the whole client API because we see that it needs to do so. We implemented the new API to make it easy to use and make it intuitive to use, because in the old client, if you work with it, it's quite hard to find some features and quickly learn from its API. Now it has the central point, entry point from where you can discover all the features and settings. We're trying to put as much documentation Java doc as we can, make the exceptions more descriptive and suitable for certain operations. Another big thing we want to present is plain Java object insertion. In previous version, you have to encode your objects manually if you want to use formats like raw binary or raw binary with defaults, and it's quite complicated task. In the new client, we implementing the auto-generated serializers, and what you need to do is to provide your class upfront the insertion. Then the client will generate serializer specifically for this class. So only the minimal set of instruction will be used at the right phase. And then just pass the collection of your objects into the insertion API, and it will be inserted with most suitable format. It also gives great boost in performance because we extracted all heavy lifting upfront. Oh, sorry. Can we return the previous slide? Thank you. Talking about the data formats, in the new client, we will extend the support of all ClickHouse formats to make it easy to use. And also we will add some support of common formats. We paid attention to how easy to configure and use the client, especially the configuration. We moved from the map of some properties to the separate objects for every operation, so a developer can understand what settings can be defined for certain operation, query or insert. This refactoring created the new artifact named client v2. It is part of the ClickHouse Java project. And now it's available since version of 0.6.1. So you can go to the Maven and check out and try. Please consider looking into examples. So here's an example of how in previous client we do mutations. On the old API, you have to do some boilerplate code. You have to create the streams and so on. And in the middle of this, you have the loop going through all your events and taking every field and encoding. In the new API, you just register your class and then do the insertion. Every heavy lifting and scaffolding is done inside the client. The next slide, please. Can we switch to the next slide, please? Oh, sorry, this one. Thank you. And this is another example where we have improvement. On the left, there is code what you need to do to configure the old client, and you can see that it is done through the map that has just the generic types. And some of the configuration is even tricky. So for example, if you want to enable the compression of requests coming from the client, you need to find the decompress option and also define that LZ4 should be used. In the new client, it is done with just one code instruction, compress client request, that's it. That's pretty much what I have for today. Current implementation is based on the old client. We're currently in the phase of refactoring the internals. Soon it will be done, and we'll update you with that. Thank you.
Yeah, thank you. I really like these examples because often when I see this amount of code in Java with a lot of statements like new factory, new callable, whatever, serializable, I think this is Java. It has to be this way. This is normal. But you showed me that it can be so much better. Yeah, I really like it. Okay. And for integrations, we have our usual updates, an update for Metabase, DBT, Node.js, Go clients, Kafka, Grafana, OpenTelemetry. And by the way, now the most popular Spark connector, that is named Spark ClickHouse connector, is officially supported by ClickHouse. Okay, what else? There is a blog, and there is a lot of stuff, a lot of interesting stuff. For example, we recently launched ClickHouse Cloud on Azure in GA. And Azure is very much different from both GCP and AWS. And we have to do a lot of customizations and specific optimizations for Azure. You can read how some companies store 50 petabytes of data in ClickHouse. And by the way, it is not anything unusual 50 petabytes is just 50 petabytes. You are not surprised with these numbers if you use ClickHouse. ClickHouse will process this optimally. About query insights, about customer experience like Shopee, Common Room, and our Trust Center, everything is covered in our blog. And now we probably have -1 minute for your questions, but maybe just give people time for 1 or 2 questions.
Yeah, let's. I think the most interesting question maybe is, can you mention something about sharded maps, Alexei? I think that's people wondering. Sergey's answering the questions on Java client in the chat. Thanks, Sergey. Can you mention what our progress is like on sharded maps and if we're still applying to do that?
This is really interesting feature, and we have a lot of expectations about this feature. It was developed for some time previous year, then it was put on hold for other priorities. But now it continued to be developed, and we see that there are not many items to finish, and it is close to completion. And with sharded maps, you will get optimal data storage for data with a lot of different keys. And it is especially useful for observability data when you have different tags, labels. And actually, this is the motivating example for sharded maps. And when we started implementing another task, probably you have seen it in a pull request named time series data storage. And this task motivated us to continue development of sharded maps. So stay tuned. Maybe the next release or the August release, and we will get it. We will get this feature.
Okay, I'll leave it up to you if you want a final question.
Yeah, please.
Okay, so plans on supporting writing lake formats, Iceberg, Delta Lake. Do we have any immediate plans to start thinking about being able to write in those formats?
I am optimist. So the answer is yes. But as much as optimist I am, I will not give you any timeline, any schedule. We will have it.
Okay, we're 4 minutes over. I can ask one final one. It's pretty. I think I answered it, but is there any reason that you should see that the sum map function wouldn't be compatible with an aggregating merge tree and being able to do incremental states on it?
No, I don't see any reason, because this function takes maps and returns maps, so it should be compatible.
Good. I answered as such.
Maybe
Okay.
it's not implemented, but if it is not implemented, we have so many ClickHouse contributors on this call, so let's address this. You can help.
Maybe that's a good issue for somebody to pick up, but I think I'll test it. I'm curious. Okay. Thanks, everybody. Over to you, Tyler.
Amazing. Thank you, Dale. As always, and I'll say this on X, Twitter, whatever form you want to use. It is your data that makes ClickHouse, the database, meaningful. Thank you for joining us. For the couple of hundred who are here today, we appreciate you. For the couple of thousand who will watch it in replay, we also appreciate you. fundamentally the best way to understand any of the features that were described today, or ClickHouse in general, is to download it and try it. And if for some reason you can't download it, though you should be able to because of the way our binaries work, feel free to go to ClickHouse Cloud and spin up a cluster and play with it for a bit. And then, most importantly, let us know what is amazing, because we love hearing happy stories, and let us know what is a problem, because we want to address that on the community call that's coming up next month. Feel free to come to clickhouse.com/Slack, join us in the Slack community, ask your questions, hit us up on GitHub, let us know of anything that we can help you with. And between now and then, enjoy, and we will see you next month. Thank you so much, everyone. Be well.